Hi, this is Shannon Henry, and today I will be discussing Secure Shell, or SSH, for ISA 4220 System Security 2 in the fall of 2019. SSH is Secure Shell Encryption, which is a network protocol that gives users a secure way to access computers over an unsecured network. This tool is particularly useful for network administrators who want to access computers without opening them to the chance of vulnerabilities. SSH allows these administrators to put files or software on a computer in a secure, encrypted manner, while not being in front of the specific device in question. SSH is a remote administration protocol that authenticates a remote user, transfers input from the client to the host, and will relay back output to the client. SSH is much more secure than other protocols that perform similar functions. It replaces unsecure protocols like Telnet, RLogin, and FTP, or the File Transfer Protocol. SSH allows all of the same functionality as these protocols, but with more security by being encrypted traffic. Next, we'll talk a bit about how SSH works. Secure Shell operates and listens on the TCP, or Transmission Control Protocol, port 22. It uses the client-server model in which one party, the client, requests a resource from the other party, the server. SSH can use 3 different types of encryption methods to authenticate the session and can use multiple of them in one session, including symmetric, asymmetric, and hashing encryption. Now I will break down some of the encryption methods that were discussed in the last slide that are used for SSH. First, I'll start with symmetric encryption. Symmetric encryption is an encryption method in which a client and server will use the same key to encrypt and decrypt the information. Basically, anyone who has access to this key will be able to access the information that is being sent. But it is still secure because the client and server never share the actual key over the connection. Someone attempting a man-in-the-middle attack would have to guess the key in order to get the correct information. Symmetric encryption creates a pair of keys where one key is used to calculate the other. This type of encryption uses the power of exponential equations to calculate keys and ensure that they are secure. They only transfer part of the equation to one another, and they can both end up with the same key. Anyone in the middle would not be able to calculate the key in a reasonable amount of time because such logarithmic equations are impossible to solve with modern computing technology in any reasonable amount of time. You can see on the image on the right how this exchange works. Now I will move on to asymmetric encryption, which is kind of similar to symmetric encryption, but uses an extra key. Asymmetric encryption uses a public key and a private key, which are a pair. The public key is only used to encrypt the information and cannot be used to decrypt it. Anyone can access this key. The private key is only known by one party, and it is used to decrypt the message. The server will be the only side to know the private key, and this secret will keep the encryption secure. Asymmetric encryption is not used to secure the entire SSH session like symmetric encryption is, but only is used during the key exchange algorithm of the symmetric encryption process. It would not be effective for the whole session because the client would not be able to get any feedback from the server. Finally, I will discuss hashing, which is a unique type of encryption, unlike symmetric and asymmetric, that is used in the SSH protocol. A one-way hash is an encryption method which is not meant to be decrypted. Basically, the message is encrypted in such a way that it cannot be mathematically undone. This creates a unique value of a fixed length for each input. This method is used to verify the authenticity of messages, which is done using HMACs, or hash method authentication codes. These codes are sent alongside the messages to verify their authenticity and integrity and prove that the hashes match. Now we will move on to hardening recommendations for the Open SSH that we will be using for our SSH protocol on our Ubuntu 18.04 LTS server. The following changes should be made to harden the SSH protocol in the etc SSH SSHD_config file. First, we will disable X11 forwarding, which would allow the server to send back commands to the client. This is a large vulnerability that, unless we need it for a specific use case, we should disable. This can be done by typing X11 forwarding no. Next, we will disable empty passwords, which ensures that every login to the SSH is authenticated with proper password protections, which can be done with permit empty passwords no. Then we should use DNS hostname checking so the SSH can verify that the client connecting maps back to the same combination of hostname and IP addresses. This is done using use DNS yes. Next, we should disable rhosts, which has a weaker authentication system that should no longer be used. And this is done using ignore rhosts yes. Continuing on with the hardening recommendations, we should set a maximum amount for login attempts to the SSH. Here I have set it to 3, but you could set it to 5 or whatever is necessary for the organization. This can be done with max auth tries and then the number that you would like to set it at. Then we should set up public key authentication because they are less prone to password and brute force attacks than a normal username password combination is. This is done using pub key authentication yes. Then we should disable root login on the SSH, which would prevent anyone from connecting as a root user, which can be done by editing permit root login no. Finally, we should set the SSH protocol to protocol 2, which enables the newest version of SSH, and this can be done with protocol 2. Here are my works cited, and thanks so much for watching.